Okay, question 18 is very different to all the questions previously. It says, using the properties of set operations, this is very important, write each of the following sets in its simplest form. Now, it doesn't say this explicitly, but what it means is that we're not going to use Venn diagrams to solve these questions. Yes, you could use a Venn diagram, but that wouldn't be correct. What we're looking for is for you to use the properties such as these to algebraically simplify the sets. Okay? You can check your answer at the end with Venn diagram, but when you see this question in a quiz, an exam, you will get no points for using a Venn diagram. So let's have a look at the first one then. The first one says A intersection B, union with A intersection B complement. What you've got to do here then is you've got to look at the properties that you found in class exercise 6. And you can see we've got associative properties, distributive, we've got the subtraction, and we've got De Morgan's law. Now, it's going to be difficult at the start, but in A, what we need to do is say, which one of these properties looks similar to what we've got here, and what we could possibly use it to simplify what we've got in A. So if we look through, doesn't look like De Morgan's law. It's not a subtraction. Could it be distributive? Well, it actually looks like this bit, doesn't it? It looks like the right-hand side of this distributive property. So, what we can do then is we're going to use that property and we're going to convert it then into the left-hand side. Now, in the table we've got A, B and C, but in our example we've got A, B complement. So what that means is when we rewrite this, we're going to have A intersection B from here, union from here, and now not C like in the table, but B complement from there. Okay, so to convert that, we've used the distributive property. Once we've used that property, then we look and say, well, can any of this now be simplified? We will look A intersection. Let's have a look at this then. B union B complement. What's that equal to? Well, again, it's one of the properties you should have picked up, is that that is equal to the universal set. So we've got A intersection the universal set. And then we say, can we simplify that any further? What is A intersection with the universal set? Well, again, from the properties that we've worked through in class exercise 6, we should know that that is A. Let's try B then. B, okay, looks a bit messy, so it's a bit more complicated than A. A complement union, A union. Okay, so let's have a look at this left-hand side. Does this look like anything, any of our properties? Doesn't look like De Morgan's, it's not a subtraction, doesn't look like the distributive, but it actually does look like this, the union of two of the things. So what we're going to do is we're going to use this property, and this left-hand side now becomes, by looking at this, becomes A complement union A. We just move the brackets, union B. And that's just from using the first property. And then we look at the right-hand side and say, right, can we simplify anything on the right-hand side? Now, it kind of looks here like it's the same property, but actually there's a sneaky little complement sign here. So we've just got to be careful of that. What we've actually got here is we've got to deal with this thing first, A union B complement. What property does that look like then? Let's not this, it's not this, it's not this, and it's this one here, isn't it? So we're going to convert A union B complement into, let's write the first bit there, A union. So it becomes A complement intersection B complement. Actually, let me just write that in red to match it up. So A union, and then we said it would be A complement intersection B complement. Because with De Morgan's law, we apply the complement to each one of these, and then we change the sign from a union to an intersection. Okay, so we've applied two rules then. Here we applied the associative property, and here we applied De Morgan's. And once we've applied that rule, we now look and see, can we simplify? Well, what's A complement A union A, or A complement union A? Again, that's going to be the universal set, union B. On the right-hand side then, what have we got? Well, this one is not as simple as this one over here. What property does this now look like? Let's rub out some of these. Does it look like the associative? No, it doesn't look like the associative. It looks like the distributive, the second one here. This is what we've got, isn't it? A union the intersection of two things. So if we then convert that into the right-hand side, so instead of A union B intersection A union C, we're going to have A union A complement intersection A union B complement. Okay, and now we look and say, right, can we simplify any further on the next line? B union with the universal set, that is going to just be the universal set. Then A union with A complement, again that's going to be the universal set. Intersection with A union B complement. Well, we don't know what, we can't simplify. We've not got a property that looks like A union B complement, so we can just leave it as it is. Super. And then let's have a look. Now we've got a lot of universal sets, so maybe we can simplify this further. Universal set intersection with A union B complement. Well, anything that intersects with the universal set just remains the same, so we can actually scrap that. We've just got A union B complement. And then again we've got the same thing, intersection with the universal set. So again we can remove that, and our final answer is A union B complement, because we can't simplify that further.